Alright, so let's look at a problem where we're going to find the critical points and inflection points of a given function. Let's say my function f of x is going to be x cubed plus 3x squared plus 10. Alright, to find the critical points, it means I'm taking the first derivative and setting it equal to 0. So that means I'm finding f prime. So this is going to be, let's see, 3x squared plus 6x. Alright, and find critical points, that means we're going to set the derivative equal to 0. So this means that 3x squared plus 6x equals 0. Alright, I want to find a critical point with x equals something, but both of my terms on my left-hand side have an x. So that means I'm going to factor it out. And along with the x, another common term I have is a 3, since 3 goes into 3 and 3 goes into 6. So we're actually going to factor out 3x. Alright, what that leaves left over in 3x squared is just going to be an x. And what that leaves left over from 6x is going to be a positive 2. So we get 3x times x plus 2 equals 0. Alright, so now let's look at both of these x's and find out what values give us 0. We can see that 3 times x plus 2, if this x is a 0 right here, that makes everything 0. So that means that one of my critical points is going to be when x equals 0. When we look here, x plus 2 equals 0 when x is a negative 2. So my other critical point will be negative 2. Alright, and now that we found these critical points, we can find if they have a relative extrema at those points. Remember, we do so by making a number line. Let's plot our points. Let's see, we're going to have 2 of them. We're going to have a negative 2 and a 0. So a number between negative infinity and negative 2 can be something like negative 3. Number between negative 2 and 0 can be negative 1. And a number between 0 and infinity can be positive 1. And again, I'm just picking these points. We could really pick anything we want as long as it's within the interval. These are just points that I thought would be pretty nice to work with. Alright, so let's start with plugging in negative 3 into my derivative function. Means I'm going to have f prime of negative 3. So plugging in negative 3 in is going to get me 3 times negative 3 squared plus 6 times negative 3. Alright, negative 3 squared is a positive 9. 9 times 3 is 27. And then 6 times negative 3 is a negative 18. So 27 minus 18. And this is a positive 9. So from the interval negative infinity to negative 2, I know that my slope will be positive. Alright, now let's try for the interval negative 2 to 0. So we're going to plug in our negative 1 value. So f prime of negative 1. So that's going to give us 3 times negative 1 squared plus 6 times negative 1. Alright, negative 1 squared is 1, so this is simply 3. And then 6 times negative 1 is a negative 6, so 3 minus 6. That gets me a negative 3. So the slope between negative 2 and 0 is negative. Alright, test our final one. It's going to be f prime of 1. That's going to be 3 times 1 squared plus 6 times 1. This is going to be 3 plus 6, which is a positive 9. So from the interval 0 to positive infinity, we have a positive slope. Alright, and from this we can see that as we approach from negative infinity to negative 2, we have an increasing slope. And as we leave negative 2, we have a decreasing slope, meaning that we're going to look something like this. So this says that at negative 2, which would be right here, that's going to be a relative maximum. And then likewise at 0, since I'm approaching with a negative slope from the left, and then leaving 0 with a positive slope to the right, that means that 0 is a minimum. So negative 2 will write max, and 0 will write min. Alright, now let's talk about how to find the inflection points of this function. Alright, so to find the inflection points, it means we need to take the second derivative and set it equal to 0. So we're going to have f double prime of x. Let's see, that derivative is going to be 6x plus 6. So that means we're going to take 6x plus 6 and set it equal to 0. Equals 0. We want to get x by itself, so we'll subtract 6 from both sides, getting a 6x equals a negative 6. Dividing both sides by 6, we'll get x equals negative 1. So negative 1 is going to be my inflection point. So similar to how we find the increasing and decreasing slopes for a critical point, we're going to be doing the same kind of idea to find the concavity up or concavity down of from my inflection point. Let's give ourselves a number line and plot negative 1. See, a number between negative infinity to negative 1 could be something like negative 2. And from negative 1 to positive infinity could be something like 0. Alright, so now that I have these numbers, we're going to plug them into our second derivative. And if we get a positive value, that means we're going to be concave up. And a negative value will mean that we're concave down. So let's see. I have a f double prime of negative 2. So that's going to be 6 times negative 2 plus 6. 6 times negative 2 is a negative 12, plus a positive 6 is a negative 6. So this is a negative up here, meaning that from the interval of negative infinity to negative 1, let's write that down here, negative infinity to negative 1, we are concave down. Concave down. Alright, now let's try our other point at 0. F double prime of 0 equals 6 times 0 plus 6. It's going to be a positive 6. So put a plus sign up here. So that means that from my interval negative 1 to positive infinity, we are concave up. Concave up.